So we'll start with the parent function of square root of x. Square root function. Equation. Well, we already have the equation. I guess I was supposed to put just the name at the top. But square root of x. Well, we'll just take this from the top, pretending we don't know what it looks like. Maybe you don't know what it looks like. Let's just do a table of values. So let's start. Let's see what we get. Let's start with negative 3. What's the square root of negative 3?
Yeah.
What's the square root of negative 3? What is that? Yeah, I root 3 is one answer. That's not wrong answer. But for this real graph, that's imaginary. It can't graph that. Same thing with negative 2 and negative 1. So those won't be on the graph. In fact, when x is less than 0, there won't be anything on our graph. It can be big, 0 or bigger. What's the square root of 0? 0. And the square root of 1? 1. I'm going to skip 2 because the square root of 2 is a number, but it's not a number that I know. It's a decimal. So yes, it's a point, but what would be the next good value of x to plug in to get us a nice answer? 4. Because the square root of 4 is
2.
And what would be the next good value of x to plug in? Because the square root of 9 is
3.
And the next good value will be off the graph here, but 16 and 4, 25 and 5, and 36 and 6. So feels like the x and y have switched from y equals x squared, but that's because this is the square root. It's the inverse function, so the x and y are switched. Let's plot those points. 0, 0, 1, 1, 4, 2, 9, 3, 16, 4 is off the graph, off the page. And so it's kind of a sideways parabola, but only half of the parabola. Speaking of only half of the parabola, do you know why it's not the whole parabola? Why can't we get... Well, x being negative would be over here. So it's not imaginary stuff. X being negative is on the left side. We already threw that out. I'm asking why can't y be negative? This confuses people all along here. If x squared equals 9, what does x equal? 3 or negative 3. But, this is a separate question, what is the square root of 9 equal to? 3, not negative 3. Those are different things. The square root only gives you a positive answer. It doesn't return a negative value. If it's an equation, you could get 2 answers. But here's another way to say it. This is a function, so you're only allowed one output. Another way to phrase it is, if it was a full parabola, then it wouldn't be a function because it wouldn't pass the vertical line test. So it's just the top half of that parabola. Okay, domain. Oh, these are things we know, right? So, Fernando, if I look at that graph, what's the domain of that function? Yep, domain is x. So left to right, where does the graph start?
The graph starts at...
Like as I move left to right.
0, 0.
So what x coordinate does it start at? 0. And how far to the right does it go? And then do I want to include 0?
Yeah, right here.
Yep.
And parentheses.
Good. So domain is the x stuff, left to right. Elisa, how about range? Good. Bracket 0 to infinity. That's the bottom to the top. Start at 0, go up from there. OCN, how about x-intercepts? Where does it cross or hit the x-axis? Those are, you're listing off like x values. I want to know where it hits the x-axis at 0, 0. When listed as a point. Eli, where does it hit the? Oh, yes.
Why would it not be negative infinity and then 0 bracket for the range?
For the range,
Because you're going bottom to top, right?
you are, but the first value you hit, you don't hit anything until you get to 0.
Oh, okay.
There's no graph down there.
Okay.
Eli, how about the y-intercept? Where does it hit the y-axis? 0, 0. I don't know that we've even done anything with asymptotes, so this one doesn't have any asymptotes. How about symmetry? You see any place you could fold it, or no? Okay, no symmetry there. An asymptote is a line that a graph gets closer and closer to, but doesn't hit. So if it looked something like that,
Those are the ones that never hit zero? Or never
well,
hit zero?
never hit the asymptote.
Oh.
This one doesn't have that, so we'll just say no. This is like a standard blank sheet for doing new functions. That's why it's like, well, why is that even on there? It's like, well, we'll hit some functions that have that stuff. So we always want to think about it, even though this one doesn't. We don't have to worry about it. Okay, the key points you have to know are kind of the same points as the parabola, but this is a sideways parabola, so we switch x and y. And just like the parabola, you don't have to memorize those points because this is the square root function, so you take the square root of 1 and get 1, you take the square root of 4 and get 2, you take the square root of 9 and get 3. Again, it's like the parabola points. Most of you have it memorized, but even if you didn't, 1 squared is 1, 2 squared is 4, 3 squared is 9. The other thing about these points that some people mess up is these are the points from the origin, not from each other. There's still people messing that up. So when it's time to go 4, 2, you don't go 4, 2 from the 1, 1 spot. You go 4, 2 from the origin. Okay, so those are our key points. Sometimes you can't get to that 9, 3 point, but we'll see what happens. So let's try the square root of x plus 3. Okay, experts. Madison, what's that plus 3? What has that done to our graph? Good, moves it up 3. All the translation rules are still the same. So we've changed functions, but we haven't changed rules on how we move the function. So we'll go up 3. That'll be our new starting point. And then we know the set of, I almost said ordered pairs, but they're not really ordered pairs. They're more like ordered directions from the starting point. So over 1, up 1, over 4, up 2, from the starting point. Not from the 1, 1 spot, but from the starting point, 4, 2. And then 9, 3. And then we've got our square root function. Questions on that? So again, the only new thing really is what does the square root function look like? After that, you know all the rules about moving it around. So that if x minus 2 is in the square root, like in there with x, Mason, what does that do to the graph? Good, right 2. So we'll go right 2. There's my starting point. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. 16, 25, 36, however far you want to go. 1, 1. 4, 2. I think these are all like 10 by 10 graphs. So 9 would put me just off the page, so you don't have to put it on there, but extra point maybe makes it look a little more accurate. Square root of x minus 2. So we've got the square root graph. It's been moved to the right too. Makes sense, hopefully. Dilation. Do you remember what dilation means? Like what that word means?
It gets bigger or smaller.
Yeah, it's like a stretch factor. So you know what's going to come then to make that happen. Let's put a 3 out front. So Layla, where's this graph going to start? It's almost a trick question. At the origin, because I haven't changed where I'm starting. But I have changed something. So Max, what's that 3 going to do? Multiply what? I mean, it is going to multiply. If we multiply both numbers, it would stretch it both directions. Which way is that 3 going to stretch things? We should ask that first. But it's out front of the x. So it's going to be a vertical stretch. Well, Max, if it's a vertical stretch, which set of coordinates would we multiply to accomplish a vertical stretch? The y's. The y's control the up and down. So normally 1, 1, 4, 2, 9, 3. But because of that stretch, we multiply our y values. All right, we always multiply the y values to accomplish the vertical stretch. So 3, 6, and 9. So 1, 3, 4, 6, and 9, 9. So I can remember our basic shape of a square root, but this one's been stretched out. And when we always do these, like you should check to make sure that what you said should happen, you actually happened. Right? It's unfortunate and sad when students like write the correct changes and then they like show all their work, but then their graph doesn't show what they said would happen. It's like just take the moment to make sure what you said would happen happens. All right, you guys are good at this. So let's just throw everything all at once at one here. Y equals -2 square root x plus 4 plus 3. Yeah. So that's like all the things wrong, not wrong, all the changes we could make are there. I think I see 4 changes. So we'll go in order. Or not in order, we'll just go ladies first, and then Mateo and Aiden will have to just take whatever's left over at the end there. Samantha, what's one of the changes you see?
Left 4.
Left 4. I like it. So the x plus 4 is left 4. Layla, what else has happened? Up 3. Okay. All right, Mateo, we've taken care of the 4 and the 3. What else has happened? So that there's a 2 and a negative. Tell me about one of those. Yes. Wait, what makes it flip? This will be flipped. And lastly, Aiden, what's that 2 do? Multiply the y values. If you want to sound fancy, you might say a vertical stretch. So we've done all of those things before. We just hadn't done them yet on a square root. We've done them on a parabola. So 1, 1, 4, 2, 9, 3. I guess I should find my starting point first. Left 4, up 3. And then what do I do with 1, 1, 4, 2, 9, 3? I can't use those. How do I fix those?
Multiplied by negative.
Okay, I heard two things, and you can do either one. So the flip and the stretch, if you want to accomplish both things, then I'm going to multiply them by negative 2. You remember that not everybody does the negative, they just know it's going to be flipped. That's fine. It's probably safer to multiply by negative, that way you don't forget to flip. But either way. So over 1 down 2. Over 4 down 4 from the original point, not from the previous point. So over 4 down 4. Then over 9 down 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And I think I can visualize what that's going to be. Right? Like my parent function looks like that. But I want to flip it and stretch it. So,
Isn't it up 3?
did I do something wrong? Left 4, up 3.
Oh, left 4. My bad. I didn't see.
Left 4, up 3.
Would that still be okay since it's like, because I'm also like non-negative, but since it's multiplied by negative 2, it would be okay.
Correct. The negative thing, we multiplied by negative 2, and so now we've got some negative numbers because we flipped it over. Okay, that's enough examples. Like the back page, we'll hold off on that. The assignment is this next worksheet, but let's say odds only. And this will be due Friday, whatever date Friday is, 19, 20, 21. And everything up through this worksheet will be due on Friday. So let's do one of these, or maybe a couple of these. Number 3 looks kind of weird. So let's talk number 3. Let's see. This one's feels like out of order. So, Emery, what's one of the changes that has happened? Oh, wait. I can see why you say that, but it's not negative 3 times the square root of x. So, there's two things you could address here.
Would you still use the 3 to multiply then? Or no?
Well,
Use the 1/2.
you use the 1/2 to multiply. So what's the 1/2 multiplier do?
It changes the 1, 1, 4, 2.
Yeah. What does it do to them?
The y values, right?
Perfect. Yes. So that will accomplish a squish, I guess. Multiplying by a half. 1/2, 1, 1.5. So this will be a squished square root. But Brooklyn, there's still that negative 3. Do you know what that does?
It goes down.
It goes down 3. It just is in the wrong spot. Like this would look a lot better if we had written, or if they had written the minus 3 at the end. But that doesn't change anything, the fact that they put it at the beginning. So down 3 to start with. And then we'll have a squished square root. I mean, they're already kind of squished. This will just be like extra squished. Over 1 up a half. Over 4 up 1. Over 9, that just is 1 off the graph. We can handle that. Up 1.5. So yeah, these are usually squished. Now we're squishing it by a half. I never remember to do this first, but read the directions. Graph each equation. State the domain and range. So So we get to remind ourselves about domain and range. Angelina, how about domain? Good. So as I read it left to right, the first x value we hit is 0, and then it goes forever after that. Scarlett, how about the range, the y values? Yep, starts at -3, goes to infinity, and we want to include -3. Starts at -3, goes up from there. Up really slowly, but it goes up forever from there. Why don't you try number 5? I don't know why they throw a 2/5 in there, just to mess with you, I guess. But try number 5. Annoying with the numbers they pick. Let's do some more. It goes through 17, so that's 9 problems for you to do.
That's the rule.
I don't think they'll ever be assigned the evens. Ben?
There's so many X's. I think you must be an expert.
Let's see. What else do we want to do? Number 9, we don't want to do it, but it's another one that feels out of order. So let's just list off what the transformations are, and then I'll leave it alone. But when it puts stuff in a different spot, sometimes it throws us off. So Hayden, what's one of the transformations to number 9? Vertical.
Everything shifts up 3.
There you go. Go with the easier explanation. A vertical translation would be the fancy way to say it. But everything shifts up 3 is the easier way to say it, and is what happens on the graph. So that +3, we usually like to see that at the end. They put it at the beginning, but it's still an up 3, because it's not in there with x. Speaking of in there with x, Haley, what's that +4 do? Left 4. So that +3 feels like it's out of place, but it's still a +3, so it still shifts it up 3. What do you notice about 15 and 17? Inequalities. So that just adds an extra step. Not a hard extra step, I don't think. So let's do 17. Audrey, what does that greater than sign mean in terms of the graph? What will we do? Shade above. So we know how to shade above. Now we're just going to graph something that's kind of new, but we're still going to shade above because that's what greater than means. Then what about, if I ask the direct question, I know you'll get it right. So I'm trying to ask a trickier question to challenge you.
Are you asking me?
Do you know what I'm going to ask you?
Well, it's either the flip or the down 2.
Okay, that's not what I was going to ask you, but those are both right.
Oh. You're good.
So I can't argue with that. Yeah, it's flipped and it's down 2.
Are you talking about the table? Like,
Not the table. What about the inequality? What else do we have to think about?
Make the dotted line.
Perfect.
Oh, sorry.
Look at you. You're answering everything. So there's a lot of stuff going on in this. It's got to be a dotted line. We've got shade above. That's after we figure out how to graph this thing. Ben told us we're going to flip it and move it down 2. There's my down 2. Maybe you know it well enough to don't have to write the table if all you're doing is flipping it over. Maybe you just know that it's 1, 1, 4, 2, 9, 3. You probably don't have to multiply by a negative, but if you want to follow the same process every time, again, some of you are not going to do this because you're like, come on, that's overkill. I can flip it. Others of you it's got a multiplier, so do the multiplication. Either way. Over 1, down 1. Over 4, down 2. Over 9, down 3. 16, 4, 25, 5, 36, 6. You get the idea. I almost did the solid line, but it's got to be a dash line. Sounds like somebody did the solid line before they thought about the dash line. And then where am I shading? Above the graph. So be careful on this one. I'm not going to shade anywhere on the left-hand side because that's not above the graph. I want to shade everywhere above the graph. So this might look kind of weird, but above the graph.
If you put in a given number, it's imaginary.
Right. There's nothing over there on the left-hand side. So maybe that's another kind of new thing, although we're still doing the same thing. You're shading above the graph. It's just the graph doesn't go forever, so we only shade where the graph is. Okay, you got like 10 minutes left. So that's enough time to work a few of them. Again, everything through this worksheet will be due on Friday. Hopefully the first 2 worksheets are finished or close to finished. And between now and Friday, you should have plenty of time to graph 9 minus 3, 6 more of them. Correct. So if you finish this before you leave, you'd be done. I would love for you to turn it in tomorrow. I'm not going to make you turn it in because that'd be forcing you to turn it in early. But if you know you're not going to be here Friday, like finish those 6 problems and let's turn it in and be done with it and not be worried about it over the break. But not required because it's not due till Friday.